This is 2C, factorising cubics. Okay, so I'm just going to give you a little overview to start off with so you can see where we're heading. Factorising cubics, same as factorising quadratics, is probably the most, not difficult, but the most intense part of cubics. So same as we had lots of methods for factorising quadratics, we are also going to have lots of methods for factorising cubics. So, but this is where we're going. Okay, I've got a cubic function here. Okay, and what's going to happen is that I am going to divide it by a factor, and that factor is actually going to be a bracket. Okay, when I've divided it, I'm going to end up with an answer like this. So my original bracket here and a quadratic function. We then factorize that quadratic function the same as we did before. So you can use simple factorization, you can use the AC method, you can use completing the square. Okay, and once you've factorized that, you will have 3 brackets. Okay, so we kind of take it from a cubic into a quadratic, and then we factorize the quadratic as normal. The difficult part here is the dividing. Okay, we're going to learn how to divide it in 2 different ways. We're going to use long division, and we're also going to use synthetic division. So just be aware that you will specifically be asked for long division occasionally. Okay, it's never asks you for synthetic division, but synthetic division takes a lot less time. So if it doesn't specify, most people go straight to synthetic, but you will need to know how to do long division as well. Okay, how we find this factor here is through the factor and remainder theorem. Okay, and then we're going to go through from start to finish factorising a cubic. Okay, so we're going to start with that long division of polynomials, and we are just going to practice the dividing. Okay, and then we're going to bring it all together later. So to start with, we're just going to divide this cubic here by this factor here. Okay, and we're going to do that using long division, which I think is, it has been a while since a few of you have used it. So we're going to set the factor out the front, and we're going to put the cubic under one of these little brackets. Okay, and we're going to go through one by one and work our way down. So I'm going to put a little separate working tab here. This might be something that you use to start with, and then as you go along, it kind of drops away, or you do it in your head. Okay, so for the first one, I have got x plus 3, and I want to get x cubed. Okay, so I've got to ask myself, what would I multiply x plus 3 by to get x cubed? Okay, and the answer for that one is I would multiply it by x squared, because that would give me x cubed, which is what I want, plus 3x squared, and put it up the top in the x squared column. And I'm going to take the answer that I got and put it underneath here. Notice how I'm lining up all my x cubed, all my x squareds. It is important in this that you keep it really neat, as it will make it easier for you. Okay, so what I'm going to do here is I am going to take this green bit away from the bit on top of it. Okay, so I'm going to go x cubed, take x cubed. It's nothing. Okay, 6x squared, take 3x squared is 3x squared. I'm then going to bring down the next term, which is plus 3x. My goal now is to get 3x squared. Okay, so I am starting off with x plus 3, as I always am. Okay, and I'm trying to get a 3x squared. And I've got to think, what would I times that by to get 3x squared? And the answer is, the answer would be 3x. So when I expand that little bit out there, I would get 3x squared plus 9x. Okay, again, my red part goes up the top, so plus 3x. And my green part goes down here. Okay. I take bottom away from the top. So 3x squared take 3x squares, nothing goes away. 3x take 9x is negative 6x. Okay, and bring down the 1. So we're going to go again. What do we have to multiply x plus 3 by to get negative 6x? Okay, and the answer is negative 6. So when we expand that out, we get negative 6x minus 18. So that goes down the bottom. And this goes up the top. So negative 6x take 6x, sorry, negative 6x take negative 6x is 0. 1 take negative 18 is plus 19. Okay, so in this case, our factor is x plus 3. Our quotient, no idea how to spell that, quotient. Is x squared plus 3x minus 6. I did just spell check that, don't worry, it's right. And my remainder is this part here, which is 19. Okay, so it's step by step by step. I would highly, highly recommend to anyone who is not incredibly comfortable with this to go through the example videos and go through quite a few of them. Okay, even pause it, try it yourself, and then play the video. This skill, if you cannot do this, you shouldn't be going any further because you're just going to get more confused. Okay, so try this first and then go on with the other stuff. Okay, so now that you're comfortable with factorizing using long division, I'm going to teach you synthetic division. Remember, this isn't always an option, okay? So make sure you can do both. So what I'm going to do, I'm going to first of all take the coefficient, which is the number in front of each term, and write them out. So my first coefficient is 1, second one is 6, 3, 1. Okay, and I'm going to put it in a box like so. Second thing I'm going to do, I'm going to take my factor over here and I'm going to find out what it would be using the null factor law. Okay, so remember this one, x plus 3 equals 0, therefore x equals negative 3. Okay, so it's just the opposite sign. We're using that again. And I'm going to pop that negative 3 out the front. Actually, I might color coordinate this. Not yet. Okay. So what I'm going to do, I'm going to bring the 1 down first to the bottom. I am then going to multiply the negative 3 by the 1, which is negative 3, and pop it here. Okay, then 6 take away 3. Done a terrible job color coordinating this. Let's make that 1. 6 take away 3 is 3. And then again, I'm going to multiply negative 3 this time by 3, which is negative 9. Okay, I'm then going to go 3 take away 9, which is negative 6. And then I'm going to multiply that by negative 3, which gives me positive 18. And 1 plus 18 gives me 19. Okay, so it doesn't really tell us much at the moment, but it's actually given us all the answers that the last example did. So you've got your quotient here. It's x squared plus 3x minus 6. Okay, and you can see from the last slide, we've got the same thing. It's this bit up here. Okay, so that's our quotient there. It's also given us the remainder. Okay, and our original factor, which is this one up here, stays the same. So it has given us all of the answers from the other one in a lot less work. But as I said, you will be asked to use long division, so make sure you can do it. You might be wondering how we figure out what brackets to use to factorize properly. So do we use x plus 1? Do we use x minus 1? You know, how are we going to know what works? So how we do that is the remainder and factor theorem. So I've got here a bit of theory. You do need to write somewhere that red part down the bottom. That is actually the formula for factor theorem, and you will use it a lot. Okay, so the factor theorem allows us to determine the remainder when one polynomial is divided by another. So one set of brackets is divided by another. If the remainder is 0, then you can use that factor because it divides exactly. Okay, so the factor theorem states that if p of a equals 0, or f of a, or y equals 0, okay, then x minus a is a factor of p of x. Okay, so let's do it through examples. It's a bit hard to get your head around just talking about it. So here I have a function f of x, and I'm going to try and find what I'm going to divide it by. Okay, so here are some of my guesses. Okay, and they are my guesses because in this course you have to guess and check to find a factor, and it's a bit mean of us to let you guess and check from numbers 1 to 100. So generally you will find that the factors will be no greater than 1 or 2, maybe 3 if you've got a really mean exam setter, but generally it's going to be 1, -1, 2, -2. So let's have a look at this. If f of x, if f of a equals 0, then x minus a is a factor. Okay, x minus a. So let's start by seeing if x plus 1 is a factor. You'll notice here that this is a negative, which means that we're going to try f of -1 and see if it works. Okay, so we're doing the opposite. So let's try it. We've already done this. We've subbed in. Let's go f of -1. And everywhere I see an x, I'm going to put a -1. Okay, so we're subbing it in. That equals -12. So that means that x plus 1 is not a factor. Let's try a different one. Let's try x minus 1. Okay, that means we're going to find f of 1 because it's the opposite sign. So we're going to go 1 cubed okay, and because I've already done these, that equals -30. So x minus 1 is not a factor. Okay, let's try x plus 2. So opposite sign, I'm going to do f of -2. Okay, and f of -2, it turns out, equals 0. That means that x plus 2 is a factor of this quadratic function. Okay, it is a factor, therefore we're going to divide the cubic function by the factor in order to factorize it. That is the factor and remainder theorems. Okay, so you use them a lot. They are trial and error. Okay, but just try 1, -1, 2, -2, and you'll get it 90% of the time in this course. So let's bring it all together and factorize this cubic. So I already know from the last slide that f of -2 equals 0. Therefore, x plus 2 is a factor. Okay, that's the first bit of information I need. So what I'm going to do is I'm going to divide this cubic by x plus 2. This time I'm going to use synthetic division, I think, to do this one. So we're going to go the coefficients of x cubed, of x squared, of x, and the constant. Okay, I'm going to put my -2 out the front, and I'm going to bring my 1 down. So -2 times 1 is -2. 3 take 2 is 1. -2 times 1 is -2. -10 take 2 is -12. -2 times -12 is +24. -24 plus 24 is 0. So I have now got x plus 2 from the start, and I've also got 1x squared plus 1x minus 12. Let's get rid of those so it doesn't look like division. See how I've got no remainder there? If you've got a remainder, you've got your factor wrong and you need to go back and change it. Okay, so this is almost factorized. I've just got to figure out this quadratic function here. Okay, in this case, I can use simple factorization. So 2 factors of -12 that add up to +1. So I've got x plus 4, x minus 3. And that's my cubic factorized. Okay, so step 1, we find the factor. Step 2, we can use long division or synthetic division and get it into one factor and one quadratic. And then we factorize that quadratic and end up with a factorized cubic. Okay. This is a long unit, so make sure you are pausing where you need to and practicing a lot of these skills.